Dear students, let's continue our practices on Mathematical Analysis 1, and today's topic is derivative of composite and inverse function. So, let me repeat the derivative of composite function, which we considered the last time. So, it is, what is composite function first of all? If we have two functions, f of x and g of x, the composition of these two functions is we denoted by this symbol, it's g of x. Or now we can write as f of g of x. So this is composition of two functions. And now let me consider the derivative of this composition. So here f of g of x derivative, it is, firstly we need to find the derivative of the main function. Here main function is f. So it is f of g of x, or we can write as f derivative just in argument g of x, and times we need to multiply to the derivative of this second function, g derivative of x. So this is derivative of composite function, composition of two functions. Okay, now let's consider example. Let's begin with the simple one, sine. Here we have just 3x squared minus 5x, for example. And we need to take the derivative of this function. Let's denote by y. So, how to find the derivative of this function? This is composite function because here we have sine x. This is first main function as f of x. And in the argument we have again function depending on x. This is g of x. And now let's start taking derivative. Here y prime it is. Now let's recall the formula for the composition of two functions. Okay, and now so here, the derivative of sine, it is cosine, yeah? So here we have cosine, just we rewrite this argument, 3x squared minus 5x, and now we need to take the derivative of this argument function, the second function. So in this case it is times in and multiply. It is 3x squared minus 5x and derivative. Okay, so y prime now it is cosine 3x squared minus 5x and times and derivative of this function now it is 6x minus 5. This is answer of our example. So we can write this one before the cosine as first function, and 6x minus 5 times cosine 3x. Let's rewrite it. Cosine 3x squared minus 5x without brackets. Multiplication here. Okay, so this is derivative of this function. And now let's consider the next type of the functions. So next examples. Here we have more examples. So for example, composite function. Okay. Y arc arcsine 1 over x squared. 1 over x squared. Okay, now here again the main one, the first function, it is arcsine, and the second function is 1 over x squared. So to find derivative of this function, we use again the formula for composition, derivative of composition of two functions. Okay, now it is y prime. Now the derivative of arcsine x, it is, let's recall, y prime here is 1 over 1 minus x squared. So in this case it is 1 over 1 minus, instead of x we have 1 over x squared, so it is 1 over x fourth in the square root, and times 1 over x squared prime. Yeah. So now if we continue, 1 minus 1 over x fourth in the square root, and 1 over x squared prime. So how to find derivative of 1 over x squared? So y prime is, we can use the derivative of ratio of two functions. So here it is the first derivative of the first one, it is just 0, derivative of constant, and minus 2x over x cubed, fourth degree, and then you have x cubed after cancelling this x. Okay, so it is minus 2x fourth degree. And now we can continue, or just in this form write answer. You can just multiply two of them and write the final answer. Okay, now the next example. So many examples, and the next one is, for example, let's write with logarithms. So y is equal to natural logarithm 1 minus x squared. So the f of x, the first function, is natural logarithm here. The second function is 1 minus x squared. And now let's find firstly the derivative of natural logarithm of x. Let's recall, so natural logarithm of x, derivative of this one is 1 over x. So in this case we have y prime. So we just recall the formula. Okay, now y prime, it is, so use this formula, 1 over x, our x is 1 minus x squared now. So 1 over 1 minus x squared times 1 minus x squared prime. Yeah, so now 1 over 1 minus x squared times derivative of this function now. It is minus 2x. If you continue, it is minus 2x over 1 minus x squared. Okay, so this is derivative of our given function. And now, next one. Let's move to the next example. So here we have, for example, y is e the power of sine square of x. So, how to find in this case our solution? So, find derivative. So, let's consider this function here. Also, we have composition of two functions. The first function is e the power of x, The second function is sine square x. So now we can use again the formula for the derivative of the composition of two functions, and we get, so y prime, it is e the derivative of e the power of x. This is e the power of x again. So e the power of sine square of x, our x is this one, and times derivative of this second function, sine square x derivative. Yes? So now let's continue. So e the power of sine square x times derivative of sine square x now. So in sine square x, here also we have again composite function. Let here separately consider this one, y sine square x. Here also we have composition of two functions. The first one, it is composite. The first function, it is power function, x squared. The second function is sine x. So it is in this case, how to find the derivative of this function? One more time, it is y prime here. The derivative of power function, it is 2 sine, here 2 minus 1, it is just 1, x, times derivative of second function, sine x. So it is cosine x. Or if we use trigonometric identities, we have sine 2x. So here we have sine 2x. This is derivative of given function. Okay. Another example. So, yeah, composition of function, maybe two functions, three functions. We consider just right now three functions here we have, yeah, or four functions. There is different in different cases we can find derivative. So, for example, the next example is arc tangent natural logarithm of 1 over x. So here, if it is clear, so here we have three functions: arctangent x, natural logarithm of x, and 1 over x. This one, yeah? So now, let's begin with arctangent x, the first one. So it is here, y prime is the derivative of arctangent x, it is 1 over 1 plus x squared. So 1 over 1 plus our x now, this one. Natural logarithm squared 1 over x. And times the derivative of argument. This is. So, and next step is 1 over 1 plus 1 over x times, and now derivative of natural logarithm of 1 over x. Here also we have two functions, natural logarithm of x and 1 over x. So again, derivative of natural logarithm of x, it is 1 over x. So 1 over x, because our x is 1 over x, times 1 over x prime. So the last function, third function now. And if we continue, so this one again to the right, times x, and times the derivative of 1 over x, it is minus 1 over x squared. So we can cancel them, and we have 1 plus natural logarithm of 1 over x squared and times here minus. We have 1 over x just. 1 over x. Okay, this is derivative of our given function. And now, let's consider the next example. So, okay, this one. We will do this one. Y, it is absolute value of x. Yeah, you can say this is very simple function, but however, absolute value of x is takes value x if x greater than or equals 0, and minus x if x less than or less than just. However, we add in here equality, here just less. So we can write in this form, yes, our absolute value function. And now we need to find derivative of this function, y prime. How? So we have, again, if we consider y prime, it is, look here, the prime of the derivative of x, it is just 1 when x greater than or equals 0, and minus 1 when x less than 0. When x less than 0. So this is, we can say, the sine function signum. Here we get the signum of x because we have minus 1. If it is 0, it is 0, and if it is 1, it is if it's greater than 0, it is 1. If it is less than 0, it is minus 1. Sine function it is. So, and we can see here we have right side derivative 1, left side derivative if is minus 1, so they are not equal. So it means it hasn't derivative. If one-sided derivatives are not equal, so there no exist derivative of this function. It's not differentiable. And now, next example. The next example is we're close to the previous one. X times absolute value of x. So here, again, let's write it. So it is x squared if x greater than or equals 0, and minus x squared if x less than 0. So, from definition of absolute value. And now, y prime is 2x, x greater than or equals 0, and minus 2x, x less than 0. This is derivative of this given function. Here again we have two-sided derivatives which are not equal. Okay, and here also we need to construct the graph of these functions. So, functions y and y derivative here, you know, it is, if it is absolute value function, it is, the graph of this function is this one, yes, and in y prime it is, so, in 1 prime it is minus 1 and 1. So here we have minus 1 minus 1. When x less than 0, it is minus 1 and 1. When x greater than or equals 0. And similarly, you can find the graph of this second function. Okay, now, in this case, the graph of this function, okay, let's do together. This one is like this, and like this, yeah? So, next part. This one and this one. This is the graph of given function, and we can find this here. We have minus 2x and minus 2x. It is like this and like this one. So this is the graph of y prime, derivative of y. It is graph of, this one is graph of y. Okay, now the next example. So calculate f prime 0 if f of x, it is e the power of minus x times cosine 3x. So firstly, we need to find derivative of this function and then put instead of x 0 the value and find the value in this point 0. So here we have f of x, f prime of x, it is the derivative of the multiplication of two functions. So minus, the first one, it is minus e the power of minus x times cosine 3x, correct? So, and plus the first function e the power of minus x times the derivative of the second function, it is minus sine 3x, and here we have composite function and 3x in derivative of 3x, it is just 3. So, continue. It is minus, we can take out minus, just minus, and e the power of minus x cosine 3x. So here we have plus 3 e the power, or just we can, okay, just 3 e the, after this one, 3 e the power of minus x sine 3x, or minus e the power of minus x, take out the brackets, and we have cosine 3x plus 3 sine 3x. Okay, now let's put 0. So if we put 0, here we have 1, here we have 0. Yes? And this one is 1. So the answer is just 1. Okay. And now I think it's clear. So next example now. Okay, so and now we have the logarithmic derivative. So if we have function y is f of x, and let's consider natural logarithm of y. So y is function, and we have natural logarithm of this function. This is composite function now. So derivative of this function is it is 1 over f of x times f prime x, because the derivative of this inside function f of x. So now find such kind of example. Y is any, for example, u the power of v. U the power of v. In generally, we will consider it. And then we can consider, for example, x the power of x, or sine x the power of x, for example. So such kind of examples. Okay, first let's consider this one, u the power of v. Here we have the first function u is depending on any function. U it is here depends on x function. For example, phi of x. V it is any other c of x. So we have two functions, u and v. So, and now we need to find derivative of this one. So let's continue. And now, can you write in this form? For example, it is taking logarithm from both sides of our equality. So it will be now natural logarithm of y and natural logarithm of uv. Yes? In brackets. So if we continue this one, it is v natural logarithm of u. Okay? So, and now let's consider the derivative of these functions. Let me write here. So, natural logarithm of y derivative and this one, v times natural logarithm of u derivative. Okay, so natural logarithm of y derivative, yeah, we should find here just derivative of this function. Now it is y, because the y it is function depending on u and v, so it will be using this one, we can write here y prime over y, y prime over y, and here let's use the formula for multiplication, derivative of the multiplication product. So it is v prime times natural logarithm of u plus v times natural logarithm of u prime. If we continue, it is y prime over y, v prime times natural logarithm of u plus v times 1 over u. Yeah? Because it is natural logarithm of u, the derivative of natural logarithm of u, it is 1 over u. And now, let's continue. So here we have y and so on, and we have here also u derivative, of course, because it is natural logarithm of u, it is u derivative over u. So now y prime, so it is now we can write y prime as multiply y to the right side, so it is y times v prime natural logarithm of u plus v times u prime over u. So now we can replace our y with u the power of y, v, u the power of v. So it is now u the power of v times this brackets v prime natural logarithm of u plus v times u prime over u. So this is, in generally, we can find the derivative of this function u the power of v, where u and v are functions depending on x. Depending on x. Okay, so now in particular, let's find for y the x the power of x. So it is this example. So here just replace u and v with x, and now very easy. So u the power of, let's write directly y prime using this formula now. This is for you as formula in generally, this one. So u the power of what? V. So it is x the power of x. Our u is x, our v is also x. So v prime, it is 1. 1 times natural logarithm of x plus v, it is x times x prime, it is 1. Our u is x, our v is also x here. So x prime, it is 1 over x. And we get here x the power of x, natural logarithm of x plus 1. So very easy now. We can find, for example, y sine x the power of x, or x squared, or 5x, or sine x the power of cosine x, by this way, by this formula. I think it's clear how to find such kind of examples. Okay, now and let's consider the following type of the function. So the derivative of implicit functions. So implicit function, it is function in the form fxy is 0. So and here how to find the derivative of this function y prime depending on x. So it is in this case firstly, so to calculate the derivative with respect to x, so the left side of equation y, taking y as a function of x here in the left side, and the second to equate this derivative to 0, and we get this one d over dx f xy 0. So this is a derivative of implicit function, and after this one, solve this equation with respect to y prime. With respect to y prime. Okay, now one example. So x squared, x cubed plus y squared minus 3axy is 0. This is implicit function because here we have x and y, and in the left side I mean, and it's equal to 0. And now we need to find y prime with respect to x, derivative of y with respect to x. Okay, so for this we should separately define our derivatives. So here we have, this is just function of depending on x, so it is 3x squared plus 2y times y prime, because this is the function of x, minus 3a, and now the derivative of the, here we have just multiplication of these two functions, yeah, x, y, and y is the function of depending on x. So here we have x, the derivative of x is y, plus x times y derivative, and it's equal to 0. And now we can find from this equation y prime. Here and here we have y prime. So, and y prime is, let's simplify this expression, and what we get here, just a minute. So it is y prime here is, let me add the like terms. So 3x squared plus 2y prime minus 3ay and minus 3xy prime. xy prime. So here it's equal to 0. It's equal to 0. And now, so what we get here? So it is, if we take out the y prime, it is 2y minus 3x equals to, let's move the other ones to the right side of our equation, and what we get here, 3ay minus 3x squared. Is it clear? So we just collect the like terms, and y prime here is 3ay minus 3x squared over 2y minus 3x. Here we have 3a, we have here a also, sorry, here we have a, and here we have ax. So if we have ax here, so at the end we have here ax. This is x. ax. So this is our solution. Derivative of the function y, and y is depending on x. Derivative of inverse function. So for example, if function y f of x has a derivative y prime which is not equal to 0, then derivative of the inverse function x, the inverse function, when we have inverse function, if we have one-to-one the functions, so and then we have inverse function, so it is x now f minus 1 of y. This is inverse function for this function. So its derivative of this function now is x prime depending on y. X depends on y now. 1 over y prime of x here. Y prime x. So that's why we need to take this condition. Y is not equal to 0. If it is equal to 0, here cannot take our derivative. Cannot find it. Or in this case, we can write, if you know, in lecture you have this symbol, so y derivative, it is differential of y over dx. And in this case, we need to write inversely, so dx over dy, it is 1 over dy over dx. dy over dx. So now, the next example on this topic now. So, in this section, it is find the derivative of inverse function to y if our y function is x plus natural logarithm of x. X plus natural logarithm of x. So we need to find the derivative of inverse function. This one. And how to find it? So let's find firstly y derivative. It is 1 plus 1 over x. Yes? So let's use now the formula for finding derivative of inverse function. This one. So it is 1 over y prime of x. Now x prime y, it is 1 over 1 plus 1 over x. If you simplify it, so it is x over x plus 1. X over x plus 1. Okay, now the next example. So, the derivatives of function are represented parametrically. So now we have parametrically derivatives. For example, if we consider two functions again, x as phi of t and y as psi of t. Here we have parameter t. So our function represented by parametrically. And now the derivative of y depending on x, if you write here in the sub-index x, it means depending on x, not depending on t. This is, if depending on t, it is just psi derivative of t. Or x prime, it is phi prime of t. In this case, y is function of x. Is it clear? So y is function of x. And now, in this case, how to find it? It is by the following formula. So y, the derivative of depending on t over x, derivative of depending on t. Using this formula, we can easily find the derivative of function represented parametrically. For example, x is a cosine t, or any function other we may take. For example, a cosine t, okay, and or just let's take any other example. For example, 2t minus 1, and y is 2t squared. So we need to find the derivative of y depending on x. So here it is y prime, one more time, t over x prime t. So y prime t, it is here, yeah, 2t. It's just in the second case. And x prime t, it is 2, just 2. So if we put here, it is 2t over 2, or just t. So this is the answer, just t. So this is function which is represented parametrically with x and y depending on t. And now let's consider one more example to inverse functions. So, for example, any function, any trigonometric function, cosine x. I think you know how to find inverse function. We showed it in our lectures in second practices, functions. So, cosine x. Find derivative of inverse function depending on y. So derivative of have to find to define derivative of inverse function. We need to find the inverse function to cosine x. It is x arc cosine of y. So this is inverse function to this function. And now find the derivative of this function, x prime y. It is, if you remember, 1 over y prime. So it is 1 over cosine x prime, or cosine x prime, it is just 1 over minus sine x, minus sine x. And now we can write here, instead of sine x, using trigonometric identity, we have minus 1 over square root of 1 minus cosine square of x. 1 minus cosine square of x. So cosine x is our y. So it is minus 1 over 1 minus y squared. We need to find this function depending on y, not depending on x, depending on y. That's why we need to use this one. We have to use this one. 1 minus, now we can replace cosine x with y squared. Or if you want to write as simple function in form yx, so we can just replace y with x, and we have y is equal to y prime is equal to 1 over 1 minus x squared. If you want to write in y and x. Okay. Let's consider the next example. So, for example, find a and b such that the function f of x is x minus b cubed minus 3x, for example, where x greater than or equals 0, and a cosine x, where ax less than 0. So find AB where f of x is differentiable. So when it is differentiable, f of x, if it is firstly continuous, of course, and what it means continuous, it means left side limit, one-sided limits are equal, exist and equal. So the second case, one-sided derivatives exist and they are also equal. So we have two condition, and for these conditions we get two. After this condition, we get two equations, which can then we can find this parameter a and b. If we have two equations and two parameters, we can find these unknown parameters a and b. Okay, let's do this example, and it will be more clear. Okay, f of x. Firstly, let's check the continuity. So I said for this, let's find the one-sided limits. So it is limit as x tends to 0 plus of the now right side limit is first function, yeah, x minus b cubed minus 3x. So here, if we find 0 plus, it is 0 minus b cubed. Let's find x tends to 0 minus. It is a cosine x. So in this case, this is, if we put 0 here, it will be 1 cosine 0 and just a. So we get here, they are equal, they should be equal. We get a is equals to minus b cubed. So this is first equation. And now let's find one-sided derivatives. So limit as x tends to plus 0 plus right-sided derivative f prime. So here we have prime of this function, derivative of this function. So it is limit as x tends to 0 plus 3 x minus b squared. Okay, 3x minus b squared minus 3. Then it is, if you put 0 plus, it is 0 minus b squared, it is b squared, it is 3b squared minus 3. Okay, now the next one, it is limit, left side derivative, x tends to 0 minus f prime x, it is limit as x tends to 0 minus. So here a, the prime of a cosine x, it is a with minus sine x. And if you put 0, it is 0. So what we get? We get the from equality of these two ones, we have the following one. 3b squared minus 3 equals to 0. Or 3b squared minus 1 equals to 0. And b is plus minus 1. b is plus minus 1. So if b is plus minus 1, then we can find a. Hence, however, we have a is minus b cubed, so we have a is minus b cubed, then a is, so we can put 1, if you put 1 here, we have minus 1. If you put minus 1, it is a1. a2 is just 1. This is b1 and b2. So b1 is 1, b2 is minus 1. So we have following parameters: a1, a2, b1, and b2. So in this way you can find 4 other functions also. One more time, you need to check continuity for this one-sided limits and equating these one-sided limits. Only in this case they will be continuous function. And then one-sided derivatives. You need to find one-sided derivatives and equating these one-sided derivatives, and then it will be differentiable. And we get the parameters in our equation. So it was the last example for today. I think it's clear. If you have any questions, you can write in discussion group. Okay, thank you for your attention. See you the next time.